Hello everybody, my name is Masoud Olia and I am a faculty here in School of Engineering in the Mechanical Engineering program, and I'm here with a problem related to power and power transmission and the topic of mechanics of materials. And as I mentioned before, I will every week or every couple of weeks I will come up with new videos, and as always, if you're interested in more videos in different topics, dynamics, mechanics of materials, vibrations, system dynamics, you can subscribe and leave a comment and like the video, and that would be of a great help, and I really appreciate that. In any case, let's look at this problem. So here we have a motor which is has a power of 10 horsepower, rotating at 900 RPM, and we want to transmit this power through these pulleys, this pulley B and pulley C. You could see the radii of them are 10-inch and 30-inch, so there is in a way ratio of 1:3, and this is connection is through a belt. So this basically is just like if you had two gears with the same dimensions, 10-inch in radius for a smaller gear and the larger gear. But here we have two pulleys connected through a belt. So power is being transmitted from here to shaft CD. So we want to find out if shaft CD is made of some material, say A36 steel, for which the modulus of rigidity is 11 million psi. What would be the minimum diameter of shaft CD? And these are the constraints we have. Based on material property, we don't want the shear stress in this shaft to be more than 20 ksi or 20,000 psi, and the angle of twist over 2 feet length of this section of this shaft not to be more than 6 degrees, so maximum of 6 degrees. So based on that, what would be the minimum diameter of the shaft CD? Okay, so first we have to figure out what is the torque acting on shaft AB, which is the same torque acting on pulley B, and then based on the ratio, put that torque, figure out what torque is acting on pulleys here, the larger pulley attached to shaft CD, and then once we have that torque, we're pretty much done, and then we can use our formulas. So you guys know that power is related to torque and angular speed, so that's how we calculate the power. So having 10 horsepower, remember 1 horsepower is 550 pound-foot per second. So 10 horsepower basically means 5,500 pound-foot per second. And if you do a conversion of RPM to radians per second, so 900 RPM, revolution per minute, you've seen this probably in other videos that I've had. 1 rev is 2 pi radians, right? And 1 minute is 60 seconds. So anytime you're trying to convert RPM to radians per second, you just go through this conversion of multiplying by 2 pi and divide by 60. So your omega becomes basically 30 pi radians per second. So let's go ahead and rearrange this equation and say torque then is power divided by omega. So power is 5,500 pound-foot per second, and our omega is 30 pi radians per second. And if you go ahead and solve for the torque comes out to be careful, 58.35 pound-foot. It's a very good idea to right away change this to pound-inch, because you see second and second cancel, radian is dimensionless, so the unit is pound-foot. So multiply it by 12 and convert it to pound-inch. So that comes out to be about 700.28 pound-inch. So what is this torque? This is the torque acting on shaft AB or this pulley B. So now using ratios, Remember, the idea is to figure out what is the torque now on this pulley, right? So torque on pulley C, which would be the same torque acting on shaft CD. We call it TC. So the ratio says, okay, this torque, this is, let's say, the torque acting on shaft or pulley B, right, or shaft AB. Using ratios or gear ratios in a way, we could say that the larger the gear, the larger the torque. So there is, the size of the gear is proportional to the torque. So basically, if you say TC over TB, and this is the torque that I calculated here, is basically torque acting on shaft AB or the pulley B, is equal to, you see, RC over RB. Since RC is 3 times, this is RC and this is RB, right? 3 times larger, so this ratio is 3. Therefore, torque C is 3 times torque B. So 3 times this number, 700. So that comes out to be about 2100.8 pound-inch. So now, once we know what is the torque acting on this shaft CD, then we're pretty much done. We have 2 constraints. So basically we say, okay, look, based on the constraint on shear stress of 20 KSI, right? We know that maximum shear stress is what? TC over J. Since this shaft, even though I didn't mention it, is a solid shaft. For a solid shaft, a much easier way to calculate shear stress is to use this equation. If you look at my other videos, I probably have shown you the derivation. I mean, it's no big deal. You just change this to d over 2c is the radius, and this is pi over 32 diameter to power 4, right? That's polar moment of inertia. And that's where you get that equation, 16 torque over pi d cube. So you can directly solve for diameter. Diameter becomes the 3rd root of what? 16 torque divided by pi tau max. Of course, we're talking about diameter of shaft CD, which relates to this torque C. So if you go ahead and plug in the numbers that we have, 16 times this torque here, 2100.8, and divided by what? Pi. Remember, this is 20 KSI, that's 20,000 PSI. And keep in mind, this is the 3rd root. We're going to get about 0.812 inch. So that is the requirement for the diameter, minimum diameter, to reach maximum of shear stress of 20 KSI in that shaft CD. Well, what about angle of twist of 6 degrees? That has to be converted to radians. Okay, 180 degrees is what? Pi radians. So that becomes actually pi divided by 30 radians. And that's what you have to use. Remember, phi is calculated based on this equation, TL over GJ. If I replace J by pi over 32 diameter to power 4, look, I can get an equation kind of similar to this and directly solve for the diameter. 32 goes up into the numerator, torque times L, right? Divided by G pi diameter to power 4. Rearrange the equation, so D becomes what? The 4th root of 32 torque times length over G pi, and the angle of twist moves to the denominator. So just be very careful with the unit, guys. 32 times torque. Again, torque is the same torque that we use over here, right? The torque acting on that pulley or the shaft, same torque. Length, 2 feet. 2 feet is 24 inches. That's where you have to be careful. Okay, let me put it in a different color. G is the material property given as 11 million PSI. This is steel. Pi. And phi, remember, it has to be in radians. And this is the 4th root. Do the calculation, and then surprisingly, actually, the two numbers are very close, 0.817. So what is the minimum diameter? You always have to go with the larger value. All right, so the minimum diameter here is 0.817 inch, right? Because if you pick the 0.812, your angle of twist would be larger than 6 degrees. So when you have a choice between two dimensions, always go with the larger one. Okay, so I hope you like this video, and if you actually like it, press that button, like, and leave a comment. As I said, I'll try to make more videos on different topics, and as always, I appreciate you guys subscribing to my channel so I make more videos. Thank you, and see you soon.